All right, so we're going to do some more practice with finding the domain of functions. And these are going to be some good ones because these are going to be some examples where you really have to be clever in how you're going to determine what values can go inside here. So just like usual, when you're taking the square root of a number, it can't be negative, you know, and assuming that we want to stay in the real numbers. So we need to make sure that x squared minus 5x minus 14 is greater than or equal to 0. So that's where we start. We want x squared minus 5x minus 14 be greater than or equal to 0. Now, what we're going to do is factor this. We're going to factor this into x minus 7 times x plus 2, and then that has to be greater than or equal to 0. So the way you can get a positive number is if they are both positive or if they were both negative. So if they're both positive, let's do that case first. Let's go over here. You know, that's positive times a positive. We'll just do that just to kind of symbolize whatever that means. So that means that x minus 7 has to be greater than or equal to 0. And we'll say, and x plus 2 has to be greater than or equal to 0. They both have to be greater than or equal to 0 at the same time. So from this, that means that x has to be greater than or equal to 7, and x has to be greater than or equal to negative 2 in this case. So let's just focus on that for now. I know we're gonna you're gonna see what happens here, but making them both positive. X has to be greater than or equal to 7, or greater 0 or positive, I guess. Or x has to be greater than or equal to negative 2. Now the other case that could happen if they're both negative. They both could be negative because the negative times the negative also makes a positive. So they're both negative. We can have that x minus 7 is less than or equal to 0, and x plus 2 is less than or equal to 0. So both of them have to work together again. So that means that x has to be less than or equal to 7, and x has to be less than or equal to negative 2. And so together it all has to work. So the way that kind of makes it easier to figure out is, or let's just go from here. For this to work, it would only make sense for x to be greater than or equal to 7, because both these have to again be true at the same time, and that would only be if x is greater than or equal to 7. But in this case, we're going to go with or now, because the other case would be that x has to be less than or equal to 7, and it has to be less than or equal to negative 2. And the only way for it to be less than or equal to each of them would be that x would have to be less than or equal to negative 2. Only if the second case would work here. And the reason we say or is because they're both going to be, it's going to be on opposite sides of the number line when we draw them. So let's see what I mean. Actually, let me put it up here so I can save some space for the next problem. X is greater than or equal to 7. So 7 over here, 0 to the right. And then negative 2 over here, 0 to the left. So it'll be in this region and this region. That'll be your answer here. Okay, let's go through another one like this so we get better practice. All right, for number 9, we have y is equal to the third root of x minus 6, and it's all over the square root of x squared minus x minus 30. So the top, it actually doesn't matter what x is, because you can actually take the third root of a negative number and it would still work. It wouldn't violate it, because you're not taking the square roots. There could be a negative number that's third root, like -8. The third root of -8 would be -2. So the top we don't got to worry about. Again, it's going to come down to the bottom. We need to make it so that x squared minus x minus 30 is greater than or equal to 0. So similar to what we did here, we're going to need to do it again there. So let's go, let's set that up over here. So we go, we need x squared minus x minus 30 needs to be greater than or equal to 0. Actually, no, it needs to be greater than 0, because it can't be 0 because we're dividing. So let's actually scratch that. This has to be greater than 0. And so let's factor this. We have x minus 6 times x plus 5 has to be greater than 0. So similar again, it would work if they're both positive. You have positive times a positive, or if they're both negative, then that would make a positive number. Just so it's similar to what we just did. We're going to look at this case now. So let's just call it case 1, I guess. Case 1 is that they're both positive. So then we have x minus 6 is greater than 0. And then x plus 5 is greater than 0. And that means then that, actually, never mind. That means that x has to be greater than 6, and x has to be greater than -5. That would be in case 1. Now for case 2, if they're both negative, if negative times a negative, so then we just go x minus 6 is less than 0, and x plus 5 is less than 0. That means then that x has to be less than 6, and x has to be less than -5. All right. And so together, let's see which of these would work. So then for this first one, for both these to be satisfied, it would only make sense x is greater than negative, or if x is greater than 6. So we have x is greater than 6, or, let's go over here. Or we have then, for this to be true, x has to be, only this one would work. X has to be less than -5. So then this would be our answer here. And number lining it up would go open circle on -5, arrow to the left, and open circle on 6, arrow to the right. We don't include 6 and -5. Really bad. It's a really bad arrow here. We're not going to include -5 and 6 because they're both we don't want to divide by 0 in this case. And there you go. I hope that helps. Good luck.